VLSos, this is a video lesson on the point slope form of a line. We're going to start with something that is probably familiar, an equation in slope-intercept form. Y is equal to 1/2 x plus 1. In general, slope-intercept form is y is equal to the slope m times x plus b, the y-intercept. Y-intercept form is very good for graphing. I can graph very quickly because I can see that the y-intercept is right there in this form, easy to and immediately read. In this case, it's 1. The y-intercept is where a line crosses the y-axis, so if this is where 1 is on the y-axis, I can place a point there. And then I can use the concept of the slope, rise over run. If I have a rise over run of 1/2, that means that for every 1 I go over, I'm going to rise 1/2. Or another way to think of it is, I'm going to rise 1 for every run of 2. I can use that concept of the slope to quickly graph some more points, and I can connect them together. Knowing this is the equation of a line, I can connect them to make the full graph of the line. If I had a graph, if I started with a graph, and I could observe where the line crosses the y-axis, and then I could observe another point to determine the slope, I can put a graph like this into slope-intercept form very quickly. Slope-intercept form is very useful, but it requires the y-intercept. It requires that we have a graph where we can observe the y-intercept, or maybe we have information where the y-intercept can be calculated. Whatever is the case, the y-intercept is a specific point that is required for this form. There's something that's more useful, or a little bit more useful in more circumstances. We could imagine that we have a graph where we know of 2 points. Let's invent a graph where we have the coordinates of 2 points and the entire line that connects them. But we can't easily observe where the y-intercept is. We could certainly do some rigor and we could calculate the y-intercept in order to put it into slope-intercept form, but we have a better, more ready form to use called point-slope form. For point-slope form, we need to know what the slope is. We're still generalizing that as m. The slope between these points could be found as the rise over the run. If every box is 1, 1, I know that I have to rise by going down, so I'm going to consider it a -2 with a run of 5. So rise of -2 over a run of 5 is my slope, -2/5. And the second thing that I need for this new point-slope form is the coordinates of any point. Not the y-intercept necessarily, but the y-intercept would do. I need the coordinates of any point at all. I have 2 points to choose from. Doesn't matter which I choose. I'm going to choose the one here with the coordinates 10, 3. Any point. In this case, I'm going to use the point at 10, 3. I can immediately write the equation of this line as y minus the y information of this point is equal to the slope times x minus the x information of this point. And I've got the equation of the whole line. If I wanted to solve for y, as many of us are used to doing, though it's unnecessary, I could solve for y by adding 3 to both sides, and I would get an equivalent equation, -2/5 times x minus 10 plus 3. In general, this form, called point-slope form, is y minus k is equal to the slope m times x minus h, where m is the slope and the coordinates hk are the coordinates of any point on the line. And we call this point slope form. It is generally more useful because the slope-intercept form requires the point to be the y-intercept, whereas the point-slope form can take any point at all, even the y-intercept would work.